Hey, everybody.
Hiya.
Hi.
Happy Friday. How you doing?
Doing well.
Welcome,
Good.
welcome. Cool. Umesh, we have a special guest today.
Oh yeah, Lukasz. I'm looking forward to hear from him.
Yeah. So for those of you who are somewhat new to the community, Lukasz is an OG. Lukasz is one of the originals. How you doing, Lukasz? It's been a little bit.
I'm doing good. I'm doing all right. A bit busy, but I always say it is very good to be busy if you are a solo consultant. So,
yeah, for sure.
Absolutely.
Yes. Yeah, I pinged Lukasz the other day and he told me that he was the business was picking up. So that's awesome, man. Good for you. That's good to hear.
Yeah.
Today we want to talk about IoT cloud platforms. I think this is sort of a nebulous area for a lot of people, especially those of us who've been around IoT for 10 plus years. When IoT exploded onto the scene, one of the first things to explode with it was these IoT cloud platforms. And then there was a lot of confusion about what they were, what they weren't, what they did, what they didn't do. And then a bunch of people threw a bunch of money at it. And then a little bit later, we came out the other side and there's not as much hype around them as there was, but they're definitely required. They're definitely a key piece of an IoT deployment. So we want to talk about that, and I couldn't think of anybody better to talk to than Lukasz. So I'm going to fire up the presentation. We'll do our normal song and dance, and then Lukasz, I'll give you an opportunity to introduce yourself a little bit and what you do and your claim to fame. And then I put together a few slides just to sort of contextualize a discussion. And then from there, we'll see where it goes. Does that sound good? Great. Let me put this in the presenter view. All right. So here's the normal song and dance. So welcome, everybody. I did a little prelude to the topic today, which is how to choose the right IoT cloud platform. I'm Brandon Lewis. I'm a technology journalist. I've been doing this for 13 or 14 or 15 years, somewhere in there. And I'm really happy to be part of the community and feel fortunate to be able to spend an hour each Friday with you guys. Umesh, you want to go next?
Hello everyone, I'm Umesh from Pune, India. I've been building embedded software and hardware for past 10 years for IoT solutions. Thank you.
Great. Ming, you're up.
So I'm Ming. I've been a Unix and Linux consultant for well over 30 years now, and working in the IoT space, designing and developing stuff for about 15 years or so.
Great. And I have a whole slide for you, Lukasz, and I didn't know if you wanted to put your email up or not, so I just put your LinkedIn. But why don't you tell us a little bit about yourself and what your experience is, what your background is, and then why we wanted to talk to you today.
Yeah. So I'm Lukasz. I'm the IoT advisor, trainer, and developer. Basically, I wear many hats. All of them are around IoT, specifically that covers both the edge logic, the cloud backend, security, and all of that. I've got a bit of history with AWS Cloud. I worked as an IoT consultant at AWS for 4 years. Participated in high-profile IoT deployments across the globe. So I know how that works inside out for huge scale deployments, and I know what might go wrong. And cloud is one of many pieces of the puzzle. So yeah, I'm open to discussion today. Feel free to throw any questions you've got to me, and I might share some stories and scars with you today as well.
That's awesome. So Lukasz was, as I said, one of the sort of OG dev heads. So we're really fortunate to grab a couple minutes of his time to talk about the IoT cloud landscape. So I wanted to start off, and Lukasz, if you think any of this is BS, just jump in and stop. But I wanted to try to contextualize this because it's sort of an amorphous term, right? Like, what's the IoT cloud? Oh, it's a place where all the data goes, right? So more than that, though, it's really like a collection of services that you need in order to facilitate scale in your IoT deployment. Now, depending on what the platform is, those services could vary. Here's what ARM says. You know, an IoT cloud is a massive network that supports IoT devices and applications, and includes infrastructure, server storage, real-time operations, processing, and then, you know, so other stuff for connecting, managing, and securing IoT devices and applications. Is this an accurate enough definition? Is there a way to drill this down to make it a little bit more tangible, Lukasz?
Well, I think it is a very broad definition, and I not necessarily agree with it, to be honest. And one thing that I would remove from this specific statement is the applications part, because IoT cloud basically facilitates communication in distributed IoT environment. And those are, of course, devices, edge gateways, and business applications or applications in general. Though applications as such are not necessarily the core part of the IoT platform, in my opinion. So, of course, we've got different types of applications. For instance, we need to have some logic that facilitates the connectivity, that manages our fleet, for instance, for automated detection of any threats that might happen across the huge attack field in the IoT deployment, right? But applications like the dashboards or business logic, or basically any business-related apps, in general, I would put them outside of the core IoT cloud and just integrate with it in a number of ways.
Yeah, and I put this list together really quickly, and I specifically didn't include logic there because the logic could happen in a lot of different places within the stack. So when you boil it down, it's like, okay, if you just want to have a loose framework of, all right, here is an IoT cloud, you know, you're going to have obviously some data storage, right? Data that you're collecting, that's got to go somewhere. You're going to have some APIs, obviously, to pass, you know, this information from the cloud off into, you know, wherever the application actually ends up being. Typically, is device management, like, at least today, like a prereq, like of an IoT cloud platform? Do you think that if you don't have the ability to do some device management, you're not really an IoT cloud, you're just sort of a cloud?
Yeah, totally. Like the DC, like the thing in Internet of Things, this is what makes the whole thing very interesting and very difficult at the same time, that we need to be able to manage huge fleet of devices. And the way I put it, that we manage our devices operated by untrusted users in untrusted environments, right? So all of that needs to be very precisely designed and implemented in order to span security across untrusted users, untrusted environments, untrusted networks, you name it. And device management actually can be decomposed into a number of use cases. Like the initial device onboarding is one of those, right? And if you claim to be an IoT platform, you'd better have at least few ways to onboard your devices or devices to work with you in secure way, but also in very scalable way. So we want to be able to onboard as many devices as you wish.
Does this imply the FOTA update capability? Is that,
Totally.
I mean,
totally, like, yeah, absolutely. Once again, if you claim to have an IoT cloud or IoT platform or whatever you call yourself, you need to ensure the secure lifecycle of your devices. So that starts from that initial onboarding of a device that is fresh out of the factory. Then you've got firmware upgrades. In some cases, we've got, especially for bigger devices, you've got the application logic, the business logic that you want to upgrade remotely. You've got the core firmware or software or operating system. And then you've got the configuration part, right? So typically you've got those three types of entities that we want to be able to remotely upgrade on those devices. And then something that is extremely important and often forgotten is secure decommissioning of your devices, because at the end of life, whatever that means and whatever when it happens, you need to be able to securely disconnect that device from your network, from your system. And if we've got any PII data, then you ensure that any private and confidential data of users of the specific device is also removed. And it is not always that easy if we talk about distributed systems with number of data storages, databases, and you name it.
Unless the device was developed by Ming, right? Who are inherently secure and self-destruct as soon as you. So
it's probably because I'm more in control of that end to end. That I'm in control of the communication as well as everything else.
I want to ask Umesh and Ming, based on what Lukasz just broke it down, here are the elements that we need to consider with for defining an IoT cloud platform. What's been your guys' experience working with IoT clouds? And, how is your perception of them? What do you think needs to be included for there to be for something to be a cloud platform? Umesh, since you deploy IoT solutions, we'll start with you.
If I choose any IoT cloud platform, I would want to see the rule engines to be added as a part of cloud. So I believe there are 4 or 5 things must have into the cloud platform to make life easy. One is device management. Second one is rule engines, then the database, and the best way to give the user or access control. And then the 5th one, I would add, the cloud platform should take care to make it easy to integrate the platform with the third-party application. So these 5 things you need, because most of the time the solution been built by the hardware and software kind of mixed skill sets. And let's say if I have a device management and I don't have a rule engines, and then if something kind of that I have to implement it by myself, that takes too much time to do that. So the role of a cloud is that you have one umbrella, let's say IoT cloud, and you solve all the problem under that. That's what my expectation is.
Sorry, I had muted myself as I was typing. Ming, how about you? Have you worked with IoT clouds, and what's your experience been?
See, that's where I don't know if I have. Not explicitly. I've not worked with things like the AWS IoT cloud and things like that. As most of what I will be doing is I've got cloud services, I've got update mechanisms, so I've got management. I suppose you can call it an IoT cloud, but I think most of the things that I do, because we own end to end, so we own from the sensor all the way through to the data processing, and we own the data communication hub, we own the cell tower, or the cell communications, that probably I've not needed to go down the road of opening things up.
So this is an interesting point, and I think, and I want to get Lukasz's take on this before we move forward. So when in early days, like I mentioned, there were a bunch of these cloud platforms that got pushed into the market really quickly. And this was also before device management was necessarily really fleshed out, and certainly before FOTA was completely fleshed out. So what ended up happening was everybody said, "Oh, okay, this is cool. There's some, you've got a connection to the cloud, and you got some rules engines." And then beyond that, I don't know if there was enough understanding or good enough marketing or whatever it was to be able to explain what the purpose of these things were, why you needed them. And I think the takeaway ended up being, oh, this is a data visualization dashboard. And that is not what the intent of this is, right? But a lot of companies came out. It's like, oh, you just are licensing me a data visualization dashboard. And if you're somebody like Ming, who's like, okay, well, I mean, I'm technically capable enough to, architect a system end to end. Why should I be paying somebody for this, right? So Lukasz, like, what's your take on that, and like how in the early days a lot of these rolled out, and sort of the misconceptions about what they are and what they aren't?
Yeah, well, I think the story is pretty interesting. So it all started with the overall hype around Internet of Things, right? Like people were throwing some huge number of connected devices, connected everything, and basically we will be in perfect world. And pretty quickly, people realized that it is not that easy actually to connect stuff to the internet or whatever external backend in secure and reliable way. So yeah, that was one of the reasons why a few platforms basically flew apart. But what you mentioned is very interesting. So there were a bunch of platforms that tried to be as generic as possible. So, and at the end, they provided you nice or not that nice dashboard that showed data from your devices, and that was more or less it. So they do not solve any business issue. And a few platforms that actually succeeded were the platforms that were very narrow in terms of domain they were focused on, right? So they provide you the business goals, business outcomes straight from the very first connected device because they were focused, let's say, on the smart buildings or rail or whatever, right? Basically, they were very focused. They know the domain. They were speaking the same language as the business owners, and they provided the value. And the other group of cloud platforms that kind of succeeded, in my opinion, were those hyperscalers, right? The platforms like AWS, Azure, Google tried and decided to let it go. But basically, companies with a global footprint that gave you something that is very hard to achieve on your own, and I'm open for discussion. So if you want to create a global scale IoT deployment, in my opinion, it is very hard to do it other way than basically leveraging a global infrastructure of hyperscalers currently, right? And I'm not saying that they've got perfect IoT offering. They are far from that, but they give you basically the connectivity and compute and storage, and you basically need to be technical savvy enough to put that to work in a way that you need it to work, right? But so those companies did not succeed as IoT platforms. They succeeded because they had like global scale network and compute resources, right? So yeah, that's my take on it. And what I truly admire are platforms that are very purpose specific. Like they know the domain they are operating in, and they expose ready product to the customers. Plus, they add functionalities for the business users to extend capabilities of the platform, right? But this is something very, very specific. It is not like they will create an SDK and will this is our SDK, this is our API. Go and build your stuff, right? Because like that doesn't give you any value, in my opinion.
I mean, I think that what you're pointing at here, and one of the things that I appreciate, and I think everybody else should appreciate too about Lukasz, is that he's really always focused on what's the business value, right? And I think that that's super important here because when we get into a situation where you say, we all remember, oh, there's going to be however many billions of whatever devices that are connected. It's like, okay, well, that's nice, but how are we going to make money? And the IoT cloud platform space is an epitome of that, right? Where it's like, okay, we can connect things. We have the technical ability to connect things to the cloud, right? Where's the value come? And to your point, it's really not about the ability to connect things to the cloud. It's about the ability to tailor a solution to a business case, right? And that often is lost, or it was lost, certainly, a lot of times at the beginning. And then people look back and say, oh, IoT failed. And it's like, I don't really know that it failed. I think it just split into an additional set of capabilities that are provided to specific domains. And if you have people who know how to make use of those capabilities in the context of the domain, then you might be cooking with gas. But on its own, it's it's hard to generate value. I have a lot of questions. Go ahead, Lukasz.
Yeah, I think that IoT basically matured. To your point, right? That the hype is over, and people tried to play with it and get burned, but few of them succeeded, and that formed the IoT, I would say, ecosystem as we know it right now, right? So this is the way I look at it. And my favorite example, because I worked with a few customers who claimed that they are not profitable as an IoT platform provider because the end users are not using the platform the way they should have, right? And then I always ask the question, okay, so what's your definition of how they should use the platform, right? Because the end user know what needs he or she got and how they want to satisfy those needs. It's not that you've got some assumptions, and because of the nature of traffic generated by those devices, you basically start losing money. So it is for me, it is always fascinating to that even nowadays, after how many years of basically IT in general and IoT in more specific, there are still software vendors that try to force users to use their product the way that they envisioned, and they don't understand that that might not work for everyone.
The customer is always wrong.
Yeah.
Umesh, so what's your experience with that? You know, with trying to deliver a technology solution, a technical solution in general, maybe to an end user audience that's not as savvy as you. You know, right now talking about the IoT cloud platform space, but in general, you know, how do you navigate that when the users don't necessarily know what the solution is that you're providing?
I think this is very interesting point that Lukasz has raised, that we have to, there are a couple of solutions that I have built where we have to seriously ask ourselves, like, does this solution even needs mobile app? Okay, does this solution really require your customer to log in, let's say, once in a month? Okay, let's say if you're monitoring utility, you're not logging in every day like you logged into your LinkedIn or something, or maybe another day. So uh, we when we build a solution, we have to be really focused on a problem, and if the customer can solve the problem apart from making business intelligence and other things. Okay, I don't want to mix that part because I think that's completely different. If we provide a solution, then what problem that it solve. And then I think the best solution I have seen so far working in a field are the minimalist solutions. So they focused, go and solve the problem, and not necessarily, you should not push the customers to use your software for no reason, because in the end they are not interested to pay anything, and then there is no profit out of it. So I think most of our businesses I have seen makes the profit out of building IoT solution is they are selling some service or some components on the top of data that they gather from the field. So let's say some component manufacturer, if they can put some device in the vehicle or something, and then they can extract the value on the top of that, you can sell something. So a real physical product you can sell. I think that's how I see the profitability comes in. Just piece of software, I have not yet seen any happy customer who is happy because there are beautiful widgets out there, beautiful button. Nobody care those buttons. That's what I have seen.
The that's an interesting point about managed services. This is becoming a thing, and a little bit later, after we get through the next slide, I want to ask Lukasz how he's seen that evolve, right? Where it's like we're provide, you know, buy your own IoT, right? We'll give you the sensors, we'll give you the cloud, we'll do everything. That's sort of been one of the evolutions. And to Lukasz's point earlier, if you're getting into a very specific domain or specific domains, it's easier to do that, right? But I got a couple of things I want to touch on first. Federico brought up an interesting point in the chat too that we'll get to a little bit later, which is AI, you know, and how it's starting to fit into the equation. But one of the things here, Lukasz, I crossed out a couple of the platforms you mentioned. Oh, not anymore. But you mentioned DIY versus off the shelf. Can you explain, what the difference is between the two of those?
Yeah, so back to my point about hyperscalers, right? The hyperscaler as, let's say, AWS, Azure, or whoever else, but those are the two main one, because they provide services to very broad customer base. They need to be vanilla flavored, right? They are as generic as one can be, and because of that, they give you all the tools, all the SDKs, that infrastructure, but at the end of the day, you are on your own. So it's not like you will basically swipe your credit card on AWS and you've got working IoT solutions. Like, you need to have really strong knowledge around the cloud itself. So AWS services, but or Azure services or whatever. You also need to understand how to design distributed systems, how to manage connectivity, how to manage identity of devices, applications, and whatnot. And so all of that adds up to really huge chunk of knowledge that either you need to build internally in your company, and probably typical customer of mine is not an IT company, right? So they don't really care about all of that, or you need to purchase that from the market, and then I can help you, or other folks can help you, but that basically creates additional costs for you. And on the flip side, something that is more purpose-built is that you basically connect to off-the-shelf platform. Let's use Clearblade, right? And they do not ask you to build anything. They've got that pre-built for you, so it is easy to deploy to your devices. It is easy to see that those devices are actually starting sending data to their backend, and you can basically push it forward to some other data storage or other applications or whatnot. So yeah, that's a huge difference, and it is very tough decision which way to go. Generally, if you've got some already profitable business, then it would be best for you to find a partner that's got off-the-shelf solution. But you might find one or you might not find one, and the alternative is do it yourself. And for do it yourself, I always give Tesla as an example, because they started as off-the-shelf type of mindset, and slowly transitioned into do it yourself. That gives them huge leverage over the competition, because now they own every single piece of the whole puzzle, and they can iterate extremely fast. They can add new features that they can optimize, and that they've got all the leverage that you essentially lose if you use off-the-shelf components, right? But the flip side is that you need to have very strong internal IT team, and not every company needs this kind of an edge, right? So you need to choose proper solution for your business.
My burning question here after hearing you just now is, with the help of somebody like you, is it possible to take a DIY solution that's pretty generic, the AWS, the Azure, right, and super tailor it to a very specific domain requirement? Like, are the platforms, do they have are they built in such a way that they can be tailored to very specific use cases, or are you better off, just looking for something, in your deployment that is already purpose built for whatever the solution is? I know it depends, but ultimately, is AWS and IoT, can they be formed to your needs?
Absolutely. For instance, I connected medical equipment to AWS cloud, right? And this is very specific field with extremely strict regulations, and you need to be sure that the whole thing will work and save people's life, essentially. So it is absolutely doable, and it is in most cases you can tailor whatever you use, for instance, the AWS in this case, to your specific needs. That is just a question of the development that you need to put in place, right? So, and this is one of the additional gains if you use hyperscaler versus some off-the-shelf component, that AWS as a hyperscaler cloud offers you unlimited compute and storage capabilities, right? So if you could put that potential to work in your favor, then that is a huge benefit over using off-the-shelf product that might not have those capabilities, or even if there are those capabilities, they might be extremely expensive if you pay for subscription type of fee. So yeah, and that's actually my role, because I work with startups, SMB companies, and a few enterprises as well. And in most cases, what the customer decides to do is they decide to build something themselves, but in a way that basically we design the whole solution together from the business perspective. So we start from business, we ensure that whatever we are doing is aligned to the business strategy, to the business goal, to a very specific business product that they want to introduce, for instance. Then we go down a level and decide whether there is off-the-shelf solution that might fit to those requirements. If there is, we can test it out. But typically, if we've got very specific requirements that is very hard to find something, then we start building that, right? And the way I like to work is I like to make the customer involved. So when I'm gone from the project, they can still operate the solution. And one of the huge benefits of using cloud is that you work with virtual infrastructure. That means that I can automate everything, right? And then it will just work without any human intervention. So that allows for scale, that optimizes costs. And if you've got a solid framework, then it is not that difficult to build your business applications on top of that framework. So this is typically where my job ends, that I build framework, I do knowledge transition, and then customer can basically extend that framework, leverage the capabilities that we created, but they've got full control over the whole system.
Umesh, one of the things that I think of immediately is like, okay, well, depending on what the use case is here, you've got to have different protocols. You've got to have different, types of data ingestion, right? You've got to have different types of memory and storage. So what are some of the places that you're deploying IoT, like IoT deployments, and then what are the requirements of the clouds that you've been interacting with, in the use cases that you support?
First of all, I have seen in industrial IoT space, the purpose built is the first preferred choice to the customers, at least to the geography that I am in. So if they can afford a platform which has been provided by a company like, let's say, Siemens or something who makes the hardware, so they work very seamlessly, right? And they do provide infrastructure in a backend and everything, so it's just a flawless. Now, most of a customer comes because they want to build something that probably saves the cost, because it's a business in the end, so they come. So in that case, then I have seen very often people try to, I mean, the first choice is to have some sort of EC2 instance, a server that they can buy from AWS rather than the cloud. And then they wanted to build, if this is the case for a sizable business, if the business is sizable enough. And some of the businesses have also a question about whether they really trust the platform and other infrastructure, how they have managed for the other business assets that they have. So I deal with very often building the cloud platform from scratch for some businesses. So it's very easy to port the infrastructure, taking it from one compute and transfer it to whatever they prefer, right? So that's how I see. And very few customers, maybe just a 10 or 15% customers are asking to customize, I mean, they use AWS or something, and then customize it to fit it to their requirement. So that's how the businesses I can see right now. But most of the customers are prefer, even if the development cost is high, because you have to have a full stack developer in that case, and the team and database and everything together. But their preferred choice is to build it in-house. So that's how I see.
For both of you, Lukasz and Umesh, have you seen these sort of managed services? Have you worked on managed services? You just brought it up, Umesh, with Siemens, right? Like, okay, buy the PLC, buy the cloud, buy the whole thing, right?
I can even add, if you talk about ignition or PTC ThingWorks, these are very, very focused, right? Even if in these businesses, even if you hate this platform, you can't get away with that, because those are the only platform that can solve the problem in that area, to making it easy to integrate with the other CAD software and other things. So I see that way. The way we have seen in 2015 and 16 the IoT landscape, wherein people thought, okay, all these trillions of devices will connect to Google or maybe IBM or something. What is happening right now is fragmenting and getting maturity, that everybody is finding their own space and fitting in there and solving. Right now it started actual solving the problem, because now they are focused with the businesses and the platform to solve that particular problem.
Lukasz, managed services. What's your take? Have you worked with them?
So actually, I've got a bit different definition of managed services because it's just of my background, right? Like from my perspective, managed services, for instance, like S3 bucket on AWS or AWS IoT Core, right? Those are managed services, and things like EC2, I try to avoid it as much as possible because. My take on building or designing IoT platform is that this is something that that will be, if successful, that will stay for quite a bit of time with the company, and that's why I don't believe in creating that cloud agnostic solutions, because then you leverage huge, you lose the huge potential of clouds, and those are the managed services, as I mentioned, a few examples of IoT Core, S3, Lambda functions, API gateways, whatever, right? And from my perspective, actually using those services, this is the one of the core factors that enables me to build such successful IoT platforms, right? Because those services provide the scalability, security out of the box. I don't really have to worry about that at all. And even better, if there is no traffic, for instance, we are just building the whole stuff, there is no need for huge upfront cost. And then there is a tricky part. So when the traffic starts to grow, of course, customers will pay more for those managed services because that's the way that they are designed. But they are, in a nutshell, a bit more expensive if you would run everything on EC2 instances. But then you need to have that scalability on your end. You need to ensure security, upgrading the OS of those EC2 instances, and that adds extra cost that is hidden and probably not worth it, in my opinion. Like it is better to use those higher level services. But if you decide to do so, then basically you're tied to a very specific cloud provider. Of course, there is a way to migrate from, let's say, AWS to Azure and switch one managed service to the other, though it is not one-to-one migration, and you need to really think what you're doing, because it is not that easy as switching a virtual machine from one cloud to the other.
There's a question over here, or a statement rather, from Federico, who says he's trying to build a platform of platforms because the IoT is fragmented. Most of the time, hybrid multi-cloud approach is needed. I think a layer on top of IoT clouds could be useful to speed up solution delivery, choosing the best technology path for the related use case. And he notes this could be an impossible mission. I don't know if it's an impossible mission. I think it may have already been done. What's your take on that?
Yeah, actually, that is like quite a few companies tried to do just that, to basically create the abstraction layer on top of AWS, Azure, Google, whatever, and provide unified APIs, unified dashboards, essentially to build your platform whenever you need. And most of those companies used Kubernetes under the hood, and most of them failed because it is actually not that easy to manage Kubernetes at scale. But there are a few that succeeded, and the Clearblade that I mentioned some time ago, they essentially did what Federico just described, right? They created their own runtime, and they can run that specific runtime on whatever hardware, that might be cloud, that might be edge, right? So basically, they try to achieve that isolation, that abstraction, that they provide the same APIs, the same dashboards, the same functionalities, and no matter where that runtime is actually executed. So, of course, it makes sense. Like this approach makes sense, though it requires extremely strong upfront development team, right? You need to design the whole thing very, very precisely. You need to develop it extremely well, and then you need to have pretty big support team that ensures that whatever you did runs smoothly or all of those clouds and is up to date. So that's a huge task, I would say. If you're just starting, Federico, well, of course, that's a great task or goal to have, but maybe try to be a bit more specific. So get a domain, a business domain that you know, and try to build solution that is, let's say, cloud agnostic, but for that specific domain. Try not to create a generic platform that can run anywhere, because that will provide very little leverage, right? And as Brandon said, there are already companies trying to do that. So, and if you are just starting, probably you would like to somehow differ what you offer, and creating yet another generic platform is not really that huge of a leverage.
Awesome. I just, if anybody has any questions or more comments, please bring them in. You can throw them in the chat wherever you are, whatever channel you're in. I asked Lukasz before we started, what questions, what talking points should we go over? And, here are a couple of the ones that he mentioned. The key factors to consider when choosing an IoT, when choosing a cloud provider, I think we sort of already went over those. Did you have anything else to add there, Lukasz, general versus IoT specific?
I don't think so. Like I shared the general approach or the checklist that you should use, and then it's all down to your business case.
Yep. And then a non-cloud skill set when switching to the cloud, is it possible? I think this is an interesting discussion point here.
Yeah, well, that is from developer's perspective. Let's say that you are a developer, then you are already familiar with some tool stack, right? And depending on the tools that you're using, I would suggest, if you want to increase your impact, right? Because you can create an application, a firmware, but you want to increase your impact and be able to manage that application or that firmware across the globe, leveraging some cloud, then I would suggest that at the first iteration, look at the SDKs provided by those clouds, and see if there is any cloud that have got SDKs that are as much tailored as possible to your current stack. So for instance, if you are a .NET developer, then Azure is your natural environment, right? You've got basically a Microsoft native stack in there, and you can leverage all your skills or your experience in working with .NET basically directly in that cloud. If you are more in the open source type of ecosystem, like Python and Node.js, this kind of stuff, then probably AWS would be better because their SDKs are more open toward those languages. And that will basically decrease the barrier of entry for you. And the thing that I always try to suggest when I got like the coaching calls, try to utilize as much experience as you got that when making that switch, right? Let's not start from ground zero, because you already got some experience as a developer, as an architect, DBA, right? And try to find basically the next step that, let's say, cloud platform that allows you to leverage as much non-cloud experience as you got that, and basically make it easier for you to enter that new path and actually provide better services to your customers. So yeah, like if you, to be honest, like whenever you use Azure or AWS, like both have got pretty solid presence everywhere, pretty solid offering in terms of services, and just pick the one that SDKs are easier for you to use.
Anything to add there, Umesh? On the whole concept of approaching the cloud, approaching IoT clouds with a non-cloud like skill set or mindset.
I would DIY cloud platform. We talked earlier a little bit. I think these are very great platform. A couple of years I have seen they have matured. I mean, they can consider leveraging that as well. Like if a Blink or something could able to solve their problem, because this is very specific to business, right? And if they have a decent development skills, then of course they can build by themselves. But if the deployment is not significant, then I would rather suggest to stay away from building something by themselves, or even to use a cloud platform, because as a business, you know from day one how you're going to progress. So let's say 6 months from today, how many deployment you're expecting, 1 year, 2 year. I think the number of devices that you're going to deploy, that will dictate what approach you're going to choose. And then you will also see how much data you're going to send, and how often you're going to send, and then how it will cost, and all this factor. If you add up, then I would say you have a 3 choice. You can use either a platform which makes it very easy, so click up the button and you can do something, and otherwise you can just build up yourself. If not every business basically a global, that is again one contradictory point I have, but yeah, otherwise you should leverage on some platforms. Yeah. And SDK, which Lukasz said, is very important. Like what, because you have to do some level of development, so it's important to pick something that close to your skill sets. Like Node.js and Python goes very well with AWS, and .NET is for Azure, right? So I think these are the points to look for. Nothing special from my side there.
This point number 3, I think, is probably the ultimate for this group, right? For the DevEds community, is extending cloud services with edge capabilities. So what do you mean by that, Lukasz? Is it, take this SDK, ninja it based on, what your specific use case is and what the devices that are deployed are? You're talking about FOTA? Are you talking about security? Are you talking about connectivity, interoperability to some level? Like, what does that mean? And how do you do it?
What does it mean? It basically means that in the IoT, we've got that thing, which is a thing. This is the typically the physical thing deployed somewhere, right? And that somewhere is then connecting through some flavor of network, typically public internet, back to the cloud, right? And basically that thing that you've got in your factory or in your office, in your car, from my perspective, when I described it to my customers, it gives you free compute and storage capabilities at the edge, because you already purchased that device. And of course, for the battery powered devices, it's a bit more complicated. But I would say that you should do and run as much compute, as much logic on the device itself, and then send only relevant data up to the cloud or even to your own backend, because typically you pay for the data transfer anyway, right? Even if you use your own hardware on the other end. So it makes sense to run as much compute as possible on those devices. But what I mean about bringing the cloud capabilities to the edge, this is actually something that very few people are aware of. That speaking about AWS, because I happened to have some history with AWS, there is a way to access private AWS services and AWS assets over public internet from your devices, if you know how to do it. And this gives you very powerful capabilities, because I've seen companies using, let's say, public S3 buckets because they need to upload some images from devices to the cloud, and public S3 bucket seems to be the best option. Well, that's not the best option. You can try to push that image through some API, or maybe even try to push it through MQTT payloads, right? But there are other ways to handle that. And if you fully use cloud capabilities, even or maybe precisely at the edge, that opens very, very interesting field for you. So basically, you can integrate your devices operated by untrusted users under untrusted environments and through untrusted networks. Still they can connect directly to your critical infrastructure in a cloud securely, and this way you can save your cost, you can increase the functionalities that you offer to the end users without compromising your security. So this is what I'm saying, that if you know what you're doing, you can leverage potential of the cloud directly from your devices that sit under your desk, for instance.
This is super interesting, and actually, Ming, I want to see what you can make of this too. So, Lukasz, we should have moved this way forward in the discussion. Are you talking about like some sort of VPN tunneling, of through a public network, and then doing some permissioning or authentication? Like how is this possible to have untrusted, unauthenticated users interacting with private services in a way that's still secure?
Yeah, well, VPN is, I would say, old school type of doing stuff. Well, it is still valid option, but it's not mandatory. Like the way that typically you work with devices, and I think this is just a general good practice, is that you never, like the backend never connects or sends the data to devices as the active actor, right? That the device should drop any incoming traffic, and it should be always the part that establish connection with AWS, with the backend, basically. Like, so the flow that you use is that you've got your device. That device first verifies the identity of the endpoint it is trying to reach. If it confirms that this is a trusted endpoint, it confirms its identity, for instance, using X509 certificate. So now what we did is we created mutual trust between those two parties, and we exchanged some crypto material in the session, and we can leverage that to basically create a secure transaction. And within the transaction, then the commands, data, PII data, whatever, can travel back and forth because the channel is already encrypted. And there are a few very interesting cases that, for instance, if you've got devices, some developers try to have kind of backdoor on those devices. So they enable remote SSH. Just in case something goes off and MQTT is not working anymore, let's use SSH directly to that device. We will do some hacking and everything will be fine. Well, that is pretty cool. Unfortunately, the same way someone from the other side of the globe can compromise your devices, right? And it is not that fun anymore. But there are ways that you can create so-called, let's say, those backdoors still in a secure way, and a way that expose those backdoors only to your systems and applications, not to everyone else, even though you are exposing them through the public internet. So it's all down to the distributed identity management, creating mutual trust between all the parties of that distributed system. And once you establish trust, then you can build the communication around boundaries of that trust. And something extremely important, trust is not only about saying that I am who I claim I am. Trust is also to confirm that what I try to do is permitted, right? Because a device should be allowed only to communicate with very specific, let's say, range of MQTT topics, if we've got MQTT as an example, and it should be allowed only to subscribe and receive very specific set of information, even though it participates in that many type of communication scenario. So that once you know how to narrow down permissions of your devices, how to confirm the identity of your devices, then you've got two gains out of that. One is that because you establish trust, then you can expose some secrets within those secured sessions that allow you to directly access some third-party services, let's say that S3 bucket, using encrypted channels. And the other thing is that you narrow down the blast radius. That means that if you've got very smart user that take your device apart, let's say extract the private key certificate, all of the credentials, and tries to use that device essentially to penetrate your system, to try to maybe compromise other devices or steal some data, then first of all, that should not be possible, because device that person uses have got very limited access only to data essentially it generates and consumes, so you cannot steal your neighbor's data. And additionally, because you should have some automated monitoring in place, that activity should be very quickly identified and device should be cut off from your network. So yeah, this is pretty long answer, but what I'm trying to say, it is not that you establish VPN and you're done, or you've got SSH and you're also done. It is more that you need to design the whole system as basically loosely coupled, connected applications and identities, and only then you can do some advanced tricks.
Wow, Ming, I was gonna give you a chance to throw a response in there, but we're almost out of time. But I think that this is certainly something we need to pull the thread.
One thing I'll just quickly say is when you're talking about like the SSH access for the system that I'm running, I use my device management with Mender that provides one of these secure but initiated from the device connections. That I've actually turned off SSH. We don't have SSH access, but I've still got remote access to my entire fleet. And it's a great secure solution.
I think totally. Sorry, go ahead, Lukasz, do you have anything to say?
No, I think this is just a good practice, right? That your device is always the active part, and then you can establish whatever communication fits your need.
Wow. Okay. Well, Lukasz, I'd love to have you back on at some point to sort of parse some of this stuff out. Ming and I have been talking in particular about some security related content that we're going to do coming up, and it would be great to get more of an end-to-end, holistic system architecture view. So I'd love to keep talking to you. But anything else to add? Anybody have any questions for Lukasz? Anybody have anything they want to address before we sign off for the week? Okay. Well, Lukasz, honestly, man, it's always great to talk to you. I'm glad to hear that you're doing well. And like I said, we'll be in touch, because I think that there's always a lot more to go through, but you're a wealth of knowledge and we really appreciate it. So Everybody, as far as what we got coming up next, there is no engineering hour this weekend, but there will be one next weekend. So this weekend, what you can look forward to is a reheat of last week's engineering hour. So that's tomorrow at 8 a.m. my time, which is 1500 UTC. And then we'll kick it off next week with more office hours and engineering hour sessions. So check those out in the server. And thanks for spending the time with us. We really appreciate it. All right, guys. I hope you have a great weekend.
Yeah. Thank you.
Bye.
Take care.
Bye.
See you, Lukasz. All right. Bye.